In the last series of videos, we created the address controller module that will allow our computer to navigate through the memory of our system. We're at the point where we can actually add in both the RAM and the ROM, and this means that we're almost to the final phase of the project, the control logic. But before we move too quickly, we still have a few more things to add. First, go back to the main project page. I'm going to move this bar graph out of the way. And then in the parts list, I'm going to drag and drop an address controller module into the project. Now in the parts menu, go to memory and select RAM. Set the address bit width to 16 and the data bit width to 8. And then change the trigger from rising edge to low level. Set the data bus implementation to 1 bidirectional data bus, then set the appearance to classic Logisim. Once all the settings for the chip match what you see on the screen, place one on the project page to the right of the address controller. Now go back to the parts menu and select ROM. Set the address bit width to 16 and change the appearance to classic Logisim. Then place the ROM chip underneath of the RAM. Now wire the address out output from the address controller to both the RAM and the ROM address inputs. Then wire the data bus to the data bus ports of the address controller. Now we're pretty close to having a functional computer, but we still got a few things to do. Firstly, remember back to the previous video, how the RAM and the ROM are split up between a fixed 16-bit wide address space. We can't have both of these chips outputting values at the same time, so we need to come up with a way to select which chip gets to be enabled, depending on the address being output by the address controller. We also need to create some logic to only allow the RAM to latch values when the control logic allows it to. Fortunately, both of these things are relatively simple to implement, and these solutions are mirrored in the real hardware. Let's start by creating the logic to select between the RAM and the ROM. Notice that the RAM chip has an output enable pin, but the ROM doesn't. So in order to give the ROM chip an output enable, we'll need to add in an 8-bit wide controlled buffer to the ROM output. Next, we'll create the address mapping circuitry, which will choose between the two chips depending on what address is trying to be accessed. For this, we'll be using a comparator chip from the arithmetic menu. In the properties for the comparator, set the data bits to 16. And set the numeric type to unsigned. Then place it on the page. Next, we'll create the value that this comparator will be making comparisons against. In the parts menu, go to wiring and select constant. In properties, set the data bit width to 16 and set the value to 0x07ff. Place this constant value beside the comparator and wire it to the bottom input. Then wire the top input to the address output of the address controller. On the output side of the comparator, the less than input will go high whenever the address being accessed is less than 0x07ff. This is the signal we'll use to switch between the ROM and the RAM. But we also need something to prevent both chips from outputting unless the control logic is trying to access one of them deliberately. Place 2 NOR gates beside the memory chips. Then create a new label called not mem output enable. Both NOR gates will take this label as one of the inputs. The other input goes to the comparator less than output. But the NOR gate closest to the ROM will have the comparator signal inverted. Then we wire the top NOR gate output to the RAM's output enable pin. And the bottom NOR gate to the controlled buffer of the ROM. going back to the tunnels for the control logic, create a new button and attach another NMEM output enable label to it. Finally, when we're trying to write values to the RAM, we need to make sure it only latches values on the low clock pulse. So just like with the register file, create an OR gate and two labels. One for not RAM write enable, and the other for the not clock signal. Wire these to the inputs of the OR gate, then wire that output to the write enable line of the RAM chip. Then create another not mem write enable flag and attach it to a button. And that's it. This is the additional logic needed to use the RAM and ROM chips. It's not too bad, right? But before we can test it, we need to create labels for all the control signals of the address controller. Same as with the ALU, create labels with the same name as the pins, and attach each one to a button. I'm also going to add in two 16-bit bar graphs above the address controller to show the program counter and the MAR. As you can see, this is starting to become a little unwieldy. There are a lot of control signals. But fortunately, we just have two small steps to go before we create the control logic, which will manage all of these flags for us. In the next video, we'll add in what are called the constant value generators, and then start working on the control logic.